really happy to be here today. Thank you for being here with me. I've been in the hall and I've seen a lot of people leaving, so thanks a lot. First, owe you an apology. There's a typo in the title. I scanned indeed 50 million images, a bit more than on the title. So I did some homework on the way to the conference. Who am I? I'm Guillaume, French guy. Used to be a network guy. You might know a tool that I'm working on, Scapy, which is a Python library dedicated to sending and receiving packets, network packets in Python. And these days, I'm doing security research for GitGuardian. GitGuardian, that's a French company, which is doing secret detection. So at first, obviously in Git and GitHub, but not only. So that's a bit disturbing. Not only in code, but we do that in messaging systems. We do that in things like Slack. And our goal is to help customers identify secrets and remediate. 2 weeks ago, we released a report called the Secrets Pro report. And this report is just, let's say, a summary of the discovery we do, like every day with secrets, the crazy world. One of the information we like in this report is the fact that people tend to leak more secrets in private repositories than in public ones. So it tends to indicate that when people feel safe, they will hardcode secrets. You can get it online. It's free. There is no paywall, no address. If you want to play with the product, it's also free. So you can just create an account, plug your GitLab instance, GitHub instance, and you will start scanning the secrets for you. But my goal today is indeed to have a look at what can attackers do with secrets. In the news, attackers are looking for secrets in many things, like PyPack packages. They're scraping websites for .env. In the past weeks, attackers have been looking for secrets in GitHub action logs with great success. It seems that they managed to hack into a Coinbase, or at least some Coinbase dependencies. That's my focus today. I want to behave as I did in the past as a pen tester or doing offensive security. So what can attackers do with secrets? In security, like in many other fields, we have frameworks to define what we do. One of them is attack. That's a way to define attacker attack path. So today, we'll target container registries, in that case, DockerHub. We start with valid credentials. Indeed, they are not valid in the sense that they are default. You don't need credentials to talk to DockerHub. So we have default credential. Then we get all of the registries, so Docker images, and then we scan for unsecured credentials. So that's the target of today. And an attacker, what he can do with a valid credential, for example, it's a valid GCP account. It will connect to GCP. It will create a new instance, for example, with a big GPU, big CPU, and it will start to do crypto mining. So basically, it's stealing your money. So that's something an attacker can do. But attackers, they don't only go after cloud credentials, they go after data. So they look for credentials for databases, S3 buckets, of course, code. And they scan also for registries. In the case of registries like PyPy, Artifactory, DockerHub, or GitHub and GitLab, one of the goals is to look for secrets, but also to perform some supply chain attacks. Something that I forgot to explain, that's what is a secret. A secret could be anything like a username, passwords, private keys, tokens that give you access to a system and give you access to the system as a regular user. So we are looking and we are going after this kind of secrets today. So first, let's have a look at the content of a Docker image. So my goal today is not to explain what is Docker, is to explain what I will do later on when scanning secrets. So first, we start with the Docker file and the Docker build command if you are using a build kit. So we build the image. Here's the name is my name, gvaladon/kubecon. And then we have the tag latest. And you push that with Docker push into a registry. One of them is DockerHub. And your image is stored within the registry into a repository. So it's a bit like a Git repository, stuff storing images. And the target today is the pull operation, and when you get an image without any authentication. So let's take one more step and have a look at what is inside a Docker image. So we start with the Docker file here, really small, few instructions. We have from, copy, run, expose, and env, and finally a CMD instruction. And here, what you can see that some instructions have what I call a side effect on the final image. They create a layer. So from will be a layer, its name is SHA-256, sorry, I'm going backwards, SHA-256:CD27, and this name is indeed the hash of the content. So if two images, they share the same from, the same base image, they will also have the same layer with the same name. Layers, they are also called blobs, and a blob is just a tarball, which is usually compressed with a gzip. Copy will create another layer. Run will create another layer. So we have 3 layers. And finally, there is some strange operation, and the build kit is doing that. It takes the Docker file, plain text, and do some transformation. Some ones are unfortunate for secrets, and then it will create another blob with a JSON config. So in an image, we have layers, config, and on top of that, we have another JSON document, which is called the manifest, which is, let's call it, a list of layers plus the config file. If you want to play with an image content, I will recommend to install a tool called Scopio. Scopio is really great. You can get an image and get the blobs on your disk and start playing with the content. So basically, scanning Docker images for secrets is as easy as scanning JSON files and files within tarballs. And we have a tool for that at GitGuardian. It's called GGShield. You can install it on your laptop, and GGShield will scan Docker images. In that example, I just forgot a AWS key in my Python code. So here we have GGShield saying that, OK, I found a key, and it's invalid. This validity thing is really important for attackers, because they are only looking at secrets that they can use. So what is a validity check? So most of the time, you take the secret, you test it against a known endpoint, and then you check for the HTTP status code. So most of the time, depending on the API, it could be a bit more complex, but it works fine. So on the right here, we have the validity checks for 2 cases. On top and in green, a valid GitHub token. And the answer is 200, the token is valid. And if it's invalid, we got 401, so the invalid token. Indeed, there is a third case. In the case you have, for example, a GitHub Enterprise, which is only accessible with a VPN. So it's not possible to test it for a public IP address. So in that case, the status that we have in our application is cannot check. That's kind of useful, because it means the secret might be valid. It's not possible to know what to do. Next, so we scanned 1 image. So what should we do to scan more images? And I'm on time, a bit fast. So the methodology is the following. We have 4 simple steps. I will skip these slides. Why? Because these steps, they map to Docker registry API endpoints. So first, when you want to scan for secrets in a Docker registry, you will look for the repositories. You'll use the catalog endpoint that will give you the list of all of the repositories. Then for each repository, you will get the list of tags. That's the second step. Third step, for each tag and repository, you will get the manifest, which is this JSON file describing the content of the image. And then you will get, from the manifest, the blob for each layer and the blob for the config. And when you have the blobs, you can scan for secrets. When you have the blobs, you also have other things than secrets. Obviously, you have the source code of the application or the compiled version of the source code. So that's for a regular registry. And DockerHub is a bit slightly different. So why? Because it's not possible to use the catalog endpoint. So it's not possible by default to enumerate the repositories, which is not what we want. There's a trick here. The trick is to use the DockerHub web search and to use a keyword. So we could use like well-known keyword like production, staging, things like will likely get you images with secrets. However, there is another problem, and that's when you use a keyword, the Docker web search only returns 10,000 results. So you need to do some tricks. For example, enumeration, like kind of brute force. You will start with AAA, AAB, AAC, and so on. So here on the right side, you have SKO, so the step we are at right now. And the Docker web search is returning the list of repositories with SKO. On the left part, that the username. On the right part, that the, let's call it the repository name. And that's great. Takes almost 1 day, and you do it quietly. And at that step, you have 1 petabyte of data. That's huge. I don't know what to do with that. I don't have the money to store that. I don't have the time to scan for that. That's 9 million repositories. The first fun fact of the day is that the most used repository is called Docker 101 tutorial. If you convert it to images, that's almost 26 million images. And as I said before, only scan 15. So my goal is to go from 11 petabytes to something else. The target is 50 terabytes, which is huge still, but that I can manage. The next step is to have a look at the tags. So you retrieve the tags. It takes like 2 or 3 days using the endpoint that I presented before. So that's step number 2. And this plot is quite interesting. It showed that most of the layers, 93% of them, they have 5 layers or less, 5 tags, or less. And that's what I used. I decided to only take repositories with at most 5 tags. So that's the second step. Second step is roughly half of what we had before, 6.5 petabytes. That's 15 million images. And the other fun fact of the day is that latest is the most used tag. So the other fun fact that took me 5 days to find that. Not really kind of waste of time. After that, we have v01, v010, and so on, that mainly version numbers. Next slide. There's a trick, not a trick, but some images are huge. So this one is 170 gigabytes. That's big. The first layer is 128 gigabytes. That's still big. That's a machine learning model, likely not containing any secrets. So what I did next, I said, okay, maybe they are big layers. I don't want to scan them twice. Let's deduplicate. If you deduplicate, you will get that. 44 million unique layers. The biggest one in the experiment was 148 gigabytes, 148 gigabytes. It means that when I try to do the screenshot, the layer disappeared. So from time to time, you have layers, and from time to time, they disappear. And to get this number, to get the layers, I had to get the config files. To get the config files from the manifest takes approximately 10 days, quite a lot of time. And the next thing, when you have config file, you can have a look at instructions. So we'll start here on the right. So on the right, we have the number of instructions. Run is the most used instruction. 30% of the instructions are run instructions. And then we have env, copy, cmd, add, and star here means everything else. Expose, entry points, and the other ones. So that's for the counts. For the size, so if you recall, we have 48 petabytes at that stage. Run, that's 70% of the total, 3.3 petabytes. And indeed, run layers are not really important. Most of the time, you will see calls to APK, APT, installation of softwares, installation of Java SDK. So what I decided to do is not to scan run layers, because that will exclude most of the volume. I will focus only on copy and add. And here, the idea is to only have a look at files that are copied into the final images. So obviously, I'm likely missing some secrets by not scanning run layers, and I will discuss that later on. We found tricks to actually identify the good layers without scanning everything. So if you do that, you go from a bit less than 1 petabyte to 412 terabytes. That's 18 million unique layers, and we need still to do one more step to go to 50. The trick here is to have a look at the add and copy layer sizes. And this graph is also interesting. So in right here, the white color, 99% of the layer are below 200 megabytes. What I decided to do is take a smaller size. So what I did, I only had a look at layers smaller than 45 megabytes. That's 90% of the layer. So at that stage, we have 60 million unique layers, with a max layer size 45. It's still 15 million images. It's just that I'm looking at less data. So if you put everything together to scan DockerHub, or indeed to scan any registry, but DockerHub is the biggest one, it took me 15 days to do the discovery phase, so identifying the repositories and the images. 3 days to scan the config files with the GitGuardian products. 20 days to download and scan the layers. And here you have the curve, which is more or less the speed of the scan over 20 days. In the end, it was Christmas time, so I was off. I didn't look at the experiment, so it took like 3 days to complete. So that's why it's super slow at the end. I was off, basically celebrating Christmas. Okay, charts, numbers. I know it's not always super fun to have a look at chart and numbers, so I try to make a short version of that. First really important point before the numbers, that's what we call at GitGuardian secret detectors. We have two types. First, the detector that we'll call specific, and as an attacker, I will go for that. Or as a pen tester, red teamer, I will go for the specific. Why? Because they belong to well-known patterns and formats. Usually, they can be mapped to specific services and providers, GitHub, GCP, AWS, and so on. And they may be automatically validated, which is the example I presented before. For GitHub, we are able to identify a GitHub token and to check it against an API. So maybe automatically validated. Why? Because the specific could be an OpenSSH private key, and obviously it's difficult to know which host to connect to. And then on the other hand, we have generic secrets. Generic secrets, they look random. We don't know the service or the provider, and we lack the context. So generic secrets are kind of difficult to automate. So I'm not saying they are not great, but a human must have a look at them. And I'm really lucky because at GitGuardian we have really great people, really great machine learning scientists, and my colleagues, they managed something really cool. They took like these generic secrets, they applied their own model, and they're able to categorize 13% of the generic secrets, which means that usually you don't know what to do with a secret, but because of this model, we're able to know if it's, for example, a Microsoft SQL Server login and password. So I think it's really great, but that's out of the scope for today. So I'm going after specific and after valid. There's one information I need to give you, the only information you need to take back home. In English, this is called a pie chart. So I'm French, we call that a camembert. That's only information you need to take back home from KubeCon. The camembert is the cheese. So 5% of the repositories, they contain a secret. That's, in other words, that's 1 out of 20. That's huge. First number. Second number, origin. Most of these secrets, they come from layers, not from config. So several possibilities. I'm scanning way more files than layers. That's why this percentage thing is not super great. Or people are not actually leaking any secret in Dockerfiles. Next slide, the best for attackers. 20% of these secrets, specific secrets, obviously, are valid. That's huge. 100,000 secrets are valid today in DockerHub. Not all detectors are equal. So this 100,000 secrets come from 230 detector types. Obviously, some of them are not super interesting for attacker. Open weather map API keys. You can get the weather in London, New York, Tokyo, Paris. Do that a lot of time. It's not an attack, not super great. But as we'll see in the next slide, we have other more powerful types for attacker. Cannot check here is really great. Again, could mean that we managed to identify a GitLab personal access token, and we also managed to identify that the host is not reachable. So these secrets are really interesting, especially for attacker in your internal network, because they can use that to do lateral movement. So they can go deeper and deeper. Types, 28% of the secret detectors are related to data storage. So for us, at GitGuardian means databases, S3 buckets, and so on. So total of these 28%, that's 140,000 secrets. 13% are valid. That's a huge number again. And the second biggest category, that's cloud provider. We have 100,000 secrets, and 50% are valid. So again, in DockerHub today, you have a lot of critical secrets for many big companies. Something I didn't tell, why I'm doing that, I'm doing responsible disclosure, because as a security researcher, that's my duty to report anything critical to companies, and in the past 4 to 5 months, I've been doing that. I will not give you names. We have a blog post on that, because from time to time, people are really happy that we give them secrets, and they put them on their wall of fame, or we have vulnerability reports. But we are finding Yeah, secrets for big companies. The last graph, this one is just crazy. 60% of the valid secrets were leaked before 2024. So it means that the more like you wait, the more secrets you find. Crazy. And for 2020, so 5 years ago, 2,000 secrets are still valid. So if you're able to grab them, you can attack someone, you can go deep in the architecture. That's, for me, this number of 2,000, that's just insane. And I'm seeing that every day. Yesterday, I was having coffee, casual coffee at breakfast. I found a valid GitHub token that gave me access to Kubernetes-related open source project. So it means that I'm able to do any kind of supply chain attack against this project. That's my breakfast. Like, do that every day. Crazy stuff. Conclusion, Docker pitfalls and takeaways. I hope some of you will not believe the next slides. So first, I guess you know Docker remembers. Here, that's a fake Docker file, but it's inspired by things I've seen. From, copy, do stuff, run npm CI, and then remove npm rc. So npm rc was added to the Docker image with the copy instruction. But the thing is, npm rc is not removed from the image. It's just removed when you actually do Docker run. And the file is still in the copy layer. And if you get the copy layer, you get the secret. So this is a pattern that is not really frequent, but you can see it. So Docker remembers. Next point is more question. My question is, are people leaking or hard-coding secrets in Dockerfile? I don't think so. In practice, there are really few hard-coded secrets in Dockerfile. So here I'm using Scopio and GQ. That's perfect tools to go fast and analyze Docker images. And you can see that someone actually tried to do echo. That's S3 client ID, client secret, echo client ID, client secret into a file. These were valid. And this pattern is not really seen really often. So what is going on? So let's have a look at the other pattern, again, Scopio and GQ. So here we have a bunch of arg instructions, env, and here, that's really, again, really crazy, insane. Leak, they appear in configs as a result of Docker build. Strange. So let's have an example. This one was just crafted for you. On top, we have a Docker file. It's really nice, this Docker file. No secret at all. The only bad stuff, let's put it that way, that the echo tests, and in that case, the password will be seen in your terminal at build time, which is, let's say, OK, just for the testing purpose. Second phase, Docker build, and we have the build arg. And for me, that's perfectly fine. I've been doing security for years, 15 years or more. I've been a developer before. And everyone told me not to hard code. Everyone told me to use env variables to pass secret. And from time to time, it's not possible to use arguments. So this looks fine. I mean, it's not hard coded. In the bottom, what you have, that's, let's call it a flat representation of the JSON config file. JSON is not really easy to put on slides, so it's just a flat version. And inside, you have the secrets, this funny way of writing kubecon in arg, env, and run layer. So it means that Docker build leaks secrets into the config. So this is just insane. So what people do usually when they find insane stuff, they go, oh, it's too crazy, and then they read the documentation. There, the big warning, build arguments and environment variables are inappropriate for passing secrets to your build because they are exposed in the final image. Instead, use secret mounts or SSH mounts, which expose secrets to your build securely. Don't do that. So don't use build arg. So what else? So that's after the camembert, that's the other thing you need to take back home. Use mount secret. But I think in the previous presentation, they also discuss this best practice, mount secrets. The only drawback for me is the way you actually use it. Run -- mount type secret is not really easy to remember. Anyway, on top, a Docker file. In the middle, the new way and clean way to pass a secret, -- secrets. So here we are mapping the random variable to secret. And the trick here, random is random. So every time you call the command, that's a new secret injected into secret. Just a trick to see if it works. And at the bottom, you have the resulting JSON config file, so no secret inside. So that's the best way to do. secrets are only accessible at build time. So that's, I guess, one of the main takeaway from this presentation. Next, another question. What if people are actually doing such bad stuff that secrets are finally leaking in run layers? So this is a fake example. Obviously, no one will ever write that. No one will ever use run env and redirect that into .env. So that could be env, config.js, setting.py. Any file storing credential that could be used by an application to do something else, for example, connect to a database. OK, might work. So let's have a look. Let's select, grep, whatever kind of tool you use. And that's just a small example of real instruction in my dataset. And actually, people are using that. So the last line here, that's my fake example, which is indeed real. People are doing that. In blue, do you know what's the blue stuff? So that's a question for you. What is the blue part? OK. So blue part, so 2 slides ago, we discussed mount secrets. So mount secrets can assign a secret to a variable, and will also give you this path, run secret. So here we have someone that is doing the best stuff in the Docker world to give a secret to an image at build time, and at the same time, it's hardcoding the secrets in the end. So this is the worst thing ever. Don't ever do that. Please tell that to anyone you love. Don't ever do that. That's the worst stuff. That's in the dataset. It's time to conclude. Brief conclusion. I'm sorry, but you are probably leaking secrets. Maybe not you, maybe a friend, maybe someone in your company. And it's not because someone in your company is doing bad stuff, it's because it's difficult. It's difficult because there's a wide range of Docker pitfalls, and I know some people that have been doing Docker for years that they didn't know for this build arc stuff. So please audit your images for hard-coded secrets. So obviously, if you use our tool, GitGuardian, it will be good. I'll be really happy. My colleagues also. Do whatever you do, you want to do. Please scan for secrets. They are really bad stuff. If you are not technical and more into the, let's call it the governance side, GRC, ISO 27001, SOC 2, whatever, please just try this year, 2025, to have an exercise. Pretend that someone in your company publicly leaked a secret. Let's call it like the AWS root accounts, and see how it goes. Can you revoke? Can you identify the developer? What will happen? That's a really good exercise. And why scanning? Why doing exercise? That's because prevention, that's my guess, is more effective than actually dealing with a leak and dealing with revocation. So that's the end of the talk. I have the QR code. You can get the slides online. If you have any question, I will be around having a coffee and trying to have a water. So yeah, you have microphone here if you have any questions.